So we got number 3 here, where we have these 2 resistors, and they're in series with the 12-volt battery, and they want to know the voltage across one. This is one of ours that takes a full circuit diagram, circuit plot, all of that stuff. So you should be looking at the rubric here, the newest one that came out, with the 5 parts that go into your grade for the Y. All right? So make sure you do look at that. Let's see, I got to get my numbers in my head. 520, 2100, 12 volts. All right, so I'm going to start off by, this is number 3. Start off by diagramming my circuit. And I'm going to, in the diagram, looking for neatness. And I'm looking for correct usage of the symbols. Now you have to excuse mine is a little messy because I'm drawing on the board. And I'll try to get it as neat as I can. 520 ohms, 2100 ohms, right? 520. All right. So there I have my correct circuit diagram. If I'm looking at my rubric, I just got 10% and I just got 20%. So I've gotten 30% so far. Then I need my correct currents with correct labels. So how many currents in this circuit? 1? Settled on 1? Are there any other takers? How many currents in this circuit? Which one? Saying 1? Final answer? 1. Because how many paths are there? Yeah. So, and it goes around in this direction. Clockwise, because it goes from positive to negative. How many junctions? Zippo, right, because there's only 1 current. How can we have a place where current can change? So, let's see how much I'm up to. Ooh, I'm up to 60% right now. Nice, I've just passed. That's kind of cool. Yes, you may. So, now, what was the verbiage on points for the plot? What does the plot have to be? What does the plot have to be? We'll come back to that question. I know it's. So I've sketched my circuit there in my plot area, and now I know on this side it's up at 12 volts. Excuse me. So all of these are the same height, and then it drops down to something less than 12 volts in between those 2 resistors. Thank you. And then it drops all the way down to 0 on the backside. So all of this is at 0. So we go up there, over and over and over and down and over and down. And then let's see, this would be 12. This would be 520 I1. And this would be 2100 I1. Question? How do I know to put them where? The green lines? Because I know that the positive side of my battery is the side, the long side, and the negative side is the small side. Yes, if you look in on your packet in the inside front cover, there's a nice listing of all the symbols used. So I know that the negative side of my battery I take at 0 volts, and my battery produces 12 volts, 12 joules per coulomb. So by going from one side of it to the other, I have to go up. I have to change 12 volts. So going from negative to positive, I go from 0 up to 12. That's how I know. Okay.
You know, here to like turn on those balloons, have this go up like that, have it like that.
Oh, this didn't go up. That's just me being
No,
poor at drawing. That just went straight across.
Okay. Then how do you know like this goes down?
Because when current passes through a resistor, the resistor uses energy, thus the voltage has to drop. Yes.
Good to know.
Good to know.
Wait, why is the right side all flat?
Because there's nothing to add energy to anything on the right side or to take away energy until you get to that resistor.
Alright, but this goes left because this is the shorter side.
Nope, that's because the long side is the positive side of my battery. And so the positive side is always up at the higher voltage.
Okay.
All right, how many loops in this equation? One loop. One loop. No junctions, one loop, so I can produce one equation. I'm going to start at the bottom left corner and go around clockwise. So I'm going to have minus 520 I1 minus 2100 I1 plus 12 equals 0. So that's my one loop. And I can solve that by 12 equals 2620 I1. So I1 equals, hold on my calculator, 12 divided by, yeah. I get my current to be 0.00458. Oh, 1, 5, 2, 7, falling out of my chair, amps. And what do they ask me to find? Let's see. The voltage across the 2100 ohm resistor. So for that, I will use V equals IR. The voltage across the 2100 ohm resistor is the current, 0.004580157 amps times the resistance, 2100 ohms. Sorry, forgot my units. And I get, because they asked me for this resistor. They asked me about the 2100 resistor. I mean, I could figure out the other one and then subtract them, right? But it seems like, well, I do the next method. So I get 9.62. 62 volts. And I hope that's my answer. Let's see if I get the right answer. 9.62. Yeah, I just wanted to see if I got the right answer. Where am I going here? Alright, we're going to do number 1 as requested. And in this we're talking about, we have this heating element, it's producing this much power, and it's connected to this voltage, and they want to know what is the resistance of the element. So this is one where circuit diagram is not needed. I don't think that shows the depth of understanding for this problem. You would need to show your understanding for power. Power is the rate. Let me finish at the middle of this, and then I'll be glad to help you individually, but I'm kind of doing this first. Is the rate energy is used, and we know things like voltage is the amount of energy each charge has. And then that it takes energy to, how about, let's put it this way, the element takes energy from the charges. Alright, so you would need a written Y for this one. Equation, now onto the how. Equation wise, we're going to use, we're looking at the power, so it's right here in the current and resistance box, and we see that we have the form, those three forms. I'm going to pick to use that power equals V squared over R, and we actually have a delta in front of that. I go back here and look at, I have a 3.2 kilowatt heater and 120 volt source. So that's 3.2 times 10 to the third watts. 120 volt source over R, solve for R. There you go.